slideshow. There we go. Okay, so hello everyone again. My name is Oleksii, and today I want to talk about CliWrap. I am an open source developer mainly, and also software consultant, but today I wanted to talk about one of my projects that is coincidentally an open source project in the .NET ecosystem, which is used for automating different CLI tasks and basically just wrapping external processes all together. This talk will be split into two parts. So for the first part, I'll do a very quick presentation. And for the second part, I will show you a bunch of examples of how you can use the library to achieve different goals, starting from the very specific usage scenarios, or like very basic usage scenarios, such as like basically running some sort of CLI and getting the output, to a very complex or very domain-specific scenarios where you would like stream that or pipe something to something else and things like that. So first of all, what is CliWrap? CliWrap is a library. It's also a NuGet package that I've started working on, I think, 5 years ago at this point. And it started kind of out of personal necessity. And I think a lot of .NET developers can relate to that, because when working with external processes, we kind of find ourselves creating a lot of helper tools or helper methods or classes, because the abstraction that .NET provides, which is the system diagnostics process, is not ideal. It has a lot of problems. It has been around since pretty much the first version of .NET Framework. And frankly, it's not as comfortable or convenient to work with as for example, the Node.js stream abstractions and process abstractions and so on. So everybody did that. In my case, my helper, I guess, methods and classes and stuff like that kind of grew into a library. And over time, I've shaped it around the different needs that I've encountered. And now it grew into this, I would say, popular project that is being used pretty widely in the .NET ecosystem. It is used in throughout the many open source projects, as well as private projects and big companies like Microsoft, Stack Overflow, and Udemy. In essence, CliWrap represents an abstraction over system diagnostics process. So it completely isolates you from all of that API. And in return, it provides something different, a different API, which is more convenient to work with for both very simple use cases, such as just launching an external process and waiting for it to finish, getting the output without worrying about deadlocks and things like that, as well as more complex use cases, such as piping, event streaming, and other things like that. In its core, it also has different features listed here, such as its fluent configuration interface, which makes setting up different parts of the execution pipeline more simple. It has very powerful and flexible support for piping, which we'll see later, as well as the fact that it's fully asynchronous and cancellation aware, which until recently, a system diagnostics process was not. And it has a very functional-oriented design, which helps make the usage of this library a lot more simple and void of errors. So what is it about CLIs that is so important that we want to wrap them? I mean, I'm sure everybody has encountered scenarios or cases where they would have to wrap some external command line interface to do one thing or another. But what is that? What is it about CLIs that is so great? In my opinion, is the fact that they're pretty much the perfect library format. The reason to that is because a command line interface, just like any other interface, consists of inputs and outputs. And in case with CLIs, those inputs and outputs are command line arguments, standard input stream, environment variables, maybe some other non-deterministic inputs and things like that. And the outputs are the exit code, standard output stream, standard error stream. So it's a very consistent and predictable contract that works the same way regardless of what language you're using. So for example, you could be building a command line interface in Node.js, but then using it from .NET or just calling it from the terminal. It doesn't matter what platform you're running, it works exactly the same way on Windows, on Linux, or Mac OS, as long as it is supported by those operating systems. And it has a very consistent protocol, which means that you can always expect it to work exactly the same. All of this, I think, makes CLI as a very good interoperability format, because you can essentially package your code and build it as a CLI so that it can be used from other languages, platform, frameworks, whatever, without too many issues. And different development frameworks, I guess you can say, provide different ways to do that. In .NET, we have the system diagnostics process, but as I mentioned earlier, it's not the greatest to work with. It has several problems. Some of them are, for example, the fact that it has a fairly poorly designed API. Those are just some things I outlined that bother me personally. Those are the fact that the process lifetime transitions are not really represented by a state machine. That means that whether the process is running, whether it's just created and is ready to run, or whether it's already exited, you can't really tell by the state of the object. You have to rely on assumptions about your code, or just knowing how your code works, which makes it difficult because sometimes you encounter errors that could have been avoided had it been separate objects. Also, some configuration properties may conflict with each other. This is the result of the fact that this class has been around for a really long time, and things were added over time, and sometimes the things that are added don't really work with previous APIs and either override the existing configuration, or throw an error, or just straight up don't work somehow. Because the state is not clearly represented, some of the other issues is that depending on the operating system, you might not access the different information provided by this class, depending on which state it is in. So if you run a process and, for example, you want to get the exit time, or the start time rather, you might not be able to do that on Linux if it has exited too fast. And it's really hard to really, first of all, even know that that's a thing, but also know how to work around to really avoid those kind of issues. And like I already mentioned, those behaviors that are inconsistent between operating systems are, pretty ubiquitous. So even though .NET, as of .NET Core, runs pretty much everywhere, you still have to add some operating system-specific logic to make sure that your program that relies on external processes does not either throw an error where you don't expect it, or just straight up works the way you want it to. And finally, the async and cancellation support is lacking. As of recently, well, kind of recently, .NET 5 introduced the wait for exit async function for process, which kind of solves the async part, but the cancellation support is still lacking. And by cancellation support, I mean a way to deterministically stop the process, or like wrap the execution of a process in an atomic function that you can cancel at any point, together with the actual process that it's bound to, which you can still do by calling kill and other methods like that, but it takes a lot of manual work that should have honestly been provided by the framework. Other issues that are not related to the API is the fact that there are a lot of different deadlock and race condition traps that you may encounter. So you may write a program that uses system diagnostics process that will work perfectly well on your machine, maybe perfectly well with some CLI that you're using at the moment. But then as soon as you test it on some like larger output, or maybe some on a different operating systems, you might encounter a problem where it just freezes and does not let your execution progress further. This is very commonly it's a common occurrence when you're not handling the output and error streams properly. It can also happen when the input stream that you're providing to the program is not terminated. Like you may not have an input stream altogether, or you may have an input stream that does not terminate, and the program may not know that it has to exit regardless. Sometimes you might just have a partially consumed input. For example, when you have a lot of standard input stream data that you want to pipe, but the program does not need all of it, it might exit, but you have to handle somehow the fact that there's still the copying process running in the background that you need to terminate. there might be some cases where a process may exit before you finish reading out of all of the output error stream data, which you also have to take into account, because just because the process exited does not mean that everything that the process, all of the resources that the process had allocated are disposed properly and things like that. And also, it's really hard to, if you want to implement your own cancellation, to properly understand if killing a process resulted in a termination by the fact that you killed it, or that it just terminated ahead of time just as you were calling that method. All of those things can be avoided, but it takes a lot of forethought, a lot of effort, and a lot of experience to do that. And finally, some of the more practical cases is where certain usage scenarios are just not really practical to implement the system diagnostics process. So some of those include just pull-based data streaming. So instead of handling the output and error streams on a push-based manner, so like making sure that you have a trigger that fires every time you have new data, you want to pull that data instead and have some sort of a wait for each, like a synchronous for each instead. That kind of stuff is hard to build. High-level piping targets that involve, piping to a delegate, for example, or piping to a string builder is, again, hard to implement because you have to do it through the low-level primitives that the process class provides. And things like process-to-process piping. So if you have a one CLI and another CLI and you want to pipe the output of one to another, again, it's really hard to do because you have to deal with the streams, all the deadlock scenarios multiplied by 2, because now you have 2 processes, essentially. So CliWrap obviously aims to solve those problems, and it does so by pretty much completely reimagining the API of interacting with external processes from the ground up. And the anatomy of CliWrap is pretty simple. It consists of basically 3 really basic states. So at the core level, when you start building out a command, you have this, a command class, which is, you can say it's equivalent to when you have a terminal and you write commands in there and press enter. So the command object is kind of equivalent to that in a code form. So a command object contains the information about how you want to execute a process. So it's the target file path, command line arguments, environment variables, working directory, pipe configuration, and things like that. You can use that object to configure those different properties using the fluent interface that I mentioned earlier. That fluent interface returns immutable objects. So every time you make a change, you're not actually influencing any of your existing instances, but creating new ones. And then, as with any process you want to eventually start it, you can do that by calling the execute async method on the command, which returns the task, a command task to be specific. So a command task is very similar to a normal task, which you can find as the system threading tasks namespace, with the exception that it has additional data. And that data is currently just the process ID, which is the ID matching the process that was created. So in other words, once you have the instructions for running the process embedded in the command object, you can call a method, and that immediately returns a task that has information about the process that it just spawned. But on top of that, as with any task, you can await it. And by awaiting it, you get a different object, which is the command result containing the exit code, the start time and exit time. So some very basic information about the process runtime. And you can see that in this 3 states, you pretty much express the entire life cycle of a process. So in the far left side, you have the state where the process hasn't been started yet. In the middle is where it has been started but hasn't exited yet or hasn't completed its execution yet. And then finally, in the right side is where the process has terminated successfully, and you can get some outputs, I guess, from it. But if you look at it from a very I guess, practical perspective, you can tell that's not very useful, because even though the command result has all of this information, it still doesn't solve the problem of dealing with the outputs, the standard output, the error stream, the input stream, and things like that. And that's where the CliWrap's piping model comes in. But before we get into it, we should look into the different high-level execution models that CliWrap provides. So instead of dealing with piping model directly, a lot of the times you don't have to do that. And all you need to do is use one of the high-level execution models. What is the high-level execution model? It's basically an extension method, which allows you, for example, instead of calling execute async, you can call execute buffered async, which implicitly pipes the standard output and error stream to memory buffers and returns, instead of command result, buffered command result, which, in addition to the properties we've shown earlier, contains standard output and error. This is kind of like a shorthand for getting the output as a string instead of like dealing with the streams in a very simple manner. Similarly, CliWrap also provides out of the box two event streaming models. One of them is the listening model, which the underlying process has its output and error streams bounded to pipe to a bounded channel. And then you can read from them using an async enumerable. So with C#8 or higher, you can just use await for each and then go through the all of the events that it produces. Similarly, you also have observe, which is kind of like listen, but the opposite direction. Instead of being a pull-based stream where you're handling the events as you're capable of, and there is like back pressure to make sure you don't get overflown with them. Observe is a push-based model where events come in and you sort of direct them somewhere else using the IObservable interface. But ultimately, they work very similarly, and observable just configures the commands in a way that binds the underlying process to special observer delegates that trigger the important demands. All of those things are pretty much like those three high-level execution models cover about 90% of the usage scenarios, which makes it so that you can use CliWrap for very specific and both simple and difficult, or like, I guess, complex use cases without much code, because it's already been written for you. So let's take a look at CliWrap more directly, because it is a library, so it makes sense to look at it from the perspective of code, and switch to a code editor. So I hope you can see I have zoomed it in before. And okay. So let's start by looking at how you can actually use this library. So first of all, before doing anything else, you kind of want to write using CliWrap to get access to all of the different APIs that it provides. But then the API is very simple because it has only one entry point. You start by writing CliWrap and then the name of the this CLI, or if it's like a specific file that you want to run, the target file path. And for this example, let's just pretend that we're writing tests for some web service and we want to spin up a Postgres database. So we want to automate Docker. And so we type in Docker. So GitHub compiler already suggests me a bunch of things, but before we get into it, once we do that, that returns a command. And on a command, there are a bunch of methods that we can use to configure different aspects of it. So we can configure the arguments, the credentials if we need to, output validation, environment variables, different pipes, and so on. So in order to run a Postgres container, we need to pass in some arguments that would tell Docker CLI what to do. So in this case, we can just use the arguments method, which has a bunch of overloads. And I'm just going to copy paste this string. And once we did that, again, like I mentioned earlier, it returns a new command that it has those arguments kind of embedded as far as its instruction goes. And we can continue configuring it, or we can call execute async, which well, spawns a new process, waits for it to finish, and gives us the results. So let's do that. And let's just run this code, which is just a simple CLI. And to see what's actually happening, let's go into Docker and look at the containers. Looks like it didn't. Oh, there we go, Postgres. Oh, there we go. Now it's running. So we can see that the Postgres container has successfully started and it's running. Not very captivating. It's a simple CLI execution, but you can already see how easy CliWrap kind of lets you do those things, because with the process class, you have to instantiate the process, pass the arguments, call the execute, and if you're not using .NET 5, you have to make your own async task completion source in order to handle async execution and so on. But this is obviously not the most exciting part of it. So let's clean it up so we can continue. One other thing I wanted to mention is the different execution states. So I did say that there is the command task, and the command result. So far, we have seen the command, which is the thing that we're configuring when we're using those methods. And then we also have the command result, which we get when we wait for the command task. But we can also use the command task itself if we say command task, and instead of, oh, I realized I forgot to wait, but that's cool. But instead of dealing with this, we can say we can get the task from execute async, and that provides us with the command task I mentioned earlier. And so at that point, we can, for example, if we have some logging or other middleware, I guess, you can just use the task and refer to its process ID to make sure that we got we log the process that has been launched. And then once we're done, we can use the await keyword to make sure we get the result. So let's try that again. Let's write out the result as well and launch this command. And then you can see we have the process ID and the result exit code, which is 0. And as before, we can see that there is a container running. So this kind of shows the different execution states. There's a chat comment. Okay, question. Let's say I need to run a website or process or application that create logs. If I wanted to read the logs, but the files related to those logs are being logged, but okay, hold on a second. There is more questions. But the process in that case, Canceller help me to definitely, we got to wait for the files to be released. I'm not sure if I understand your question, but if certain files are being locked, that does not really have much to do with wrapping CLIs. You can use, I suppose, the built-in system tools to check if the file is locked. I know there is something in Windows. I'm not sure so much if there is in Linux. And then you can periodically check if it's unlocked. So I guess in that sense, it can. But if you're dealing with some files that are locked, regardless of whether you're using CliWrap or I guess process directly, it wouldn't really make a difference. Hi, Oleksii. I wonder how to handle the interaction with the process. It is waiting for our response. Imagine the CLI app doesn't support the forced approach that we have to pass the YN answer. That's an excellent question, and I'm going to leave it until later because I'm going to show exactly how to do that. But before that, let's move on with the next demonstration. So what I showed you is just basically executing a task or executing a command, getting a task, awaiting it, which is great and everything. But sometimes we also want to get the output. And like I said, CliWrap provides a few different execution models or high-level execution models that makes those things easier. And one of those is accessible by using the execute buffered async method instead of the execute async method. It also comes from a different namespace. Let me just replace this entire code so it doesn't separately deal with a task. And everything is pretty much the same, but by replacing the execute async method with execute buffer, we get access to a different result once we await the task, which is the buffer comment result. And as expected, the difference between that and the buffer command result is that it has the output and error streams buffered. So by the time the process finished, we can see what it wrote to the console. Again, in case with Docker, let's just run it, and we can see we got some output back, which is the ID of the container that it ran. So this is, for example, useful as I said in tasks if we want to run a container for our database and we want to know what ID corresponds to that container so we can, for example, shut it down later. This is something we can do simply by using the execute buffered async method instead. Other than that, it works exactly the same. You can also refer to the task directly, and the execution works pretty much exactly the same. The other thing you can do, or the other benefit I should say of execute buffered async, is that it also has an interesting way of handling errors. So let's go back to our previous example, but this time I will specifically put in arguments that don't make sense, right? So instead of Postgres as the image name, I use Postgres with 3 S's, which does not exist, and I expect this command to fail. So if you're using process directly, you kind of have to deal with failures yourself. You have to check the exit code, make sure that it is 0 or potentially even referring to the standard error to figure out what went wrong. The CliWrap, it comes by default in the form of an exception. So here we see that the execution fails, saying that the underlying process reported a non-zero exit code, and we can see exactly which command caused that to happen. Of course, if you want to log it, you might want to sanitize, passwords and things like that, but it is useful during debugging to figure out what went wrong. The other advantage of execute buffer that I mentioned earlier is that it also changes the error of the exception that is produced in case that we have an error in our command. So if I try to run it again, it fails again, but it also has the standard error since it's already buffered. So we can see exactly what went wrong. And in this case, it's because there's no image called Postgres with 3 S's, and we might either want to pull it, but it's probably going to fail anyway because it doesn't exist. But in any case, we can see that we have the option, or we have more information into what exactly went wrong. We also have the option of disabling this if we want by calling with validation, command result validation none. Another question, can we get the output while the process is running, or do we get it only after the process is finished? We can get the output while it's running. And again, I'll get to it a little bit later, because I want to show the more basic scenarios first, which are still very important in my opinion. So the other thing I wanted to show is the different ways you can put arguments or pass arguments to the command. So here we're just passing it as a string, which is, well, it works well if our string is pretty much constant, it doesn't change, we know exactly what it is, and that works great. This is also the main way you can specify the arguments using the system diagnostics process. But let's say the parser did not come in as a constant, but it was referenced from the input somewhere. And just so it happened that it contained, 2 words. So as you can imagine, this wouldn't go too well because you would want to escape the space. And in fact, the command failed altogether because it treats the world part as another argument instead of part of being the argument to the E option. And so it thinks the world is actually the image name instead of Postgres. So the usual way to deal with it is either like put on parentheses, or not parentheses, but quotes. And maybe like if you're more advanced or like you have more experience working with the command line, you know that sometimes the quotes themselves need to be escaped, and sometimes there are slashes that need to be escaped as well. And so you might want to use a helper method, but with CliWrap, it's not necessary. So in CliWrap, instead of doing it with this simple approach, you can just use a different overload with arguments, which is, for example, the array overload. And this works exactly the same, but the difference is that the Postgres password equals blah, blah, blah argument is passed as a single element to the list of arguments that we want to encode in this command. And what it means is that CliWrap knows that if it's a single argument, it has to be encoded as such. And in case of the spaces, it needs to escape the spaces automatically. So if we run it this time, we are not getting an error. Instead our command finished. Then we can see that in the environment section of this container, we can see the Postgres password was set correctly to hello world, which is helpful because we don't need to deal with escaping, which is more complicated than just putting quotes a lot of the times. So it's nice to have the library deal with it for us instead. Another overload, since we're on the subject of the argument formatting, is the builder overload, which takes it a level further and allows you to, well, the way it works is that it provides a builder class, arguments builder, that you can call add onto. And then the add method has a lot of different overloads for different types of values. So it can either take just a string value directly with optional escaping, a formatable value if you have like an integer or something else, and by default it would use the invariant culture, or maybe even multiple values, in which case it will handle them all as separate arguments. But ultimately it works the same. With one very interesting advantage is that for an argument builder, you can also define your own extension methods, since it's just a class. So in this case, I have this CLI extensions class where I defined an extension for arguments builder called add option. And sometimes it's just, you know, annoying to have to specify the name of the option, the value of the option separately, especially if the value is not always set. So for example, if the value is null, I don't want the option to be passed altogether. So I create an extension here for my own needs that does that. So if the value is not set, it just doesn't do anything, and otherwise sets the name and value. So now instead of using, you know, like setting the arguments directly, we can do something like this. So let's say we have a network parameter, and we need to reference our class. We have a network parameter, assuming it comes from somewhere from outside as an input. And instead of, you know, having to do add network and pass the value, we can just use our extension method that will handle also the case if it's not set. So if I, for example, let's set it to an empty string, which in this case will be nothing, it will run as if the network option has never been passed. So we have our container running with, I guess, the default network or no network, regardless of what it was set. But if we set it to something else and we run it, it will crash because we don't have that network created. So this time it passed the value, and because, you know, the network does not exist, the Docker daemon returned an error, which was, well, what we expected. So to summarize, when we're setting arguments, there are three main ways. You can set them as just a regular string. You can also set them as an array of strings, or you can use the builder overload. The difference is that you should probably only use the string overload if your arguments are just a constant string of values that does not really change, does not have any inputs or variables in it. And if you do, then you should probably use either the array overload or the builder overload because they're more convenient. And in the case with the builder overload, you can also set up your own extension methods that make sense for your domain or for your CLIs. Okay, so now people were asking, how can you run a command while handling the output as it appears instead of like waiting for the process to exit. And in CliWrap, everything is based on the piping model. And as far as the high-level execution models go, there's already one defined for this exact use case, which is the event streaming model. So we can go back to what we were doing, but instead of detaching, or like instead of waiting detaching from the Docker daemon and waiting until the process completes, we can instead run the container and handle everything, all of the outputs from the container ourselves. So we start by creating a command the same way, except we don't pass the detach option that would, detach ourselves from the process. And then we can use the new await for each syntax added in C#8 to handle the different execution events that the command generates. So we would do var cmd event, and then we could call, instead of execute buffered or execute async, we would just call listen async. Then here we get different command events. And if you look at the command events, and also in the documentation tells you what those can be. It can be either the start of the command event when the command starts executing, output and error events for when each time it writes a new line to the output and error, and finally exit command event when it finishes executing. So I'm just going to copy this large switch statement, which allows us to handle all of those cases. So we can use the pattern matching feature in C# to detect which event we're dealing with. If it's started, we're just going to write it out to the console. If it's standard output, we're going to write it in white color. If it's error, in dark red. And then once it's exited, we're going to print out the exit code and whatnot. So let's start it. As you can see, we already have a bunch of things in the output. Let me zoom in. If we scroll up, it started with the process started, entry in the log with the process ID. And then for each standard output line, we have the output and error lines in our own console output window, because that's where we rooted it. Of course, like we could also deal with it in any other ways. Instead of just writing it to the console ourselves, we could deal with it by like either logging it or maybe calling some methods depending on the output, and so on and so forth. And the important part is that this program still executes. So as you can see, I still have this red button allowing me to stop it. That's because the Docker CLI is running until the container exits or gets killed, I suppose. So all of this output and error has been received as it goes. And the advantage of the pull-based model, which is provided by the listen async method, is that we can handle all of those events separately and basically take our time, because there's back pressure making sure that new events don't arrive so too fast, basically overflowing our buffers and making it hard to deal with processes that provide a lot of output in a short period of time. And as we can see, also that was the previous one with the network, but this container is still running. And if we stop it from running by shutting it down, the command also terminates execution. And because it ended or exited with a non-zero exit code, it through an exception. So let me take a look at the questions, as I've seen that there's quite a lot of coming in. Okay, thanks for answering to the previous question. Another question is, if I wanted to get performance metrics, can we use CliWrap for that goal? For instance, if I wanted to check how much time a Postgres database inside Docker is taking to fire up, or how much is taken to shut down, can we use CliWrap to get those metrics? Yes, you can. So at the base level, so if you're, for example, just using the execute buffer async method, you get the exit time or even runtime properties that you can inspect and get this information, so you know how much the process has been running for. If it's not that you're interested in, for example, you're not interested in the entire duration the process has been running, but only how long it took to start the database, again, you can handle the different events or parse the output using one of the different methods and calculate those metrics yourself. A seller result has exit time, so you can calculate it. Yes. Can we start select command under specific user credential? For example, we have system user 1 and user 2, and we need run select command under user 2 credentials. Yes, you can, as Vladislav has answered, you can use it with credentials. So other options that you have when you're configuring your command, it's among other things with credentials, which allows you to set the username, password, domain. So if you're on Linux or Mac OS, you would only typically set username, but if you're on Windows, you might also want to set domain and password. And that allows you to run the process under a different user, essentially. The rest is pretty much exactly the same. Why haven't you used regular delegate-based C# events for this? The reason for this is because, first of all, you can do that too. But in this particular example, I wanted to showcase how you can use the pull-based model. The thing with events is that they're inherently push-based. So when something happens that triggers an event, you have to deal with that result. And you can't like invert that model to say that I want a stream of all the events and then handle them in sort of like a progressive manner like this. I mean, you can using channels and other methods, but at its core, it's a completely different mental model. And CliWrap provides that as well, but the more convenient, at least in my opinion, model is the pull-based one, because it allows you to think of the events as a stream instead of like discrete firings of different delegates, and handle them as they come in, while also having like this implicit back pressure. So let's say there is a std out event that we're interested in, and we're handling it, and let's say we're running some really expensive operation that takes a long time, a new event will not be produced until then. And what that means in practice is that all of the output and error streams will freeze until the buffer are filled. And if the process writes or tries to write something else, they will have to wait until you handle this event, which would be much harder to implement with the push-based model. But if you do want to use a push-based model, you can use, instead of listen async, you can also use observe, which returns IObservable. And in that case, you can use either just like directly use subscribe and create your own observer, or if you use the system reactive extensions, you can use the link queue type extensions for observable to map it to different outputs or handle them on like different schedulers and stuff like that. So that option is also available. And in this case, there's not going to be any back pressure, because all of the events trigger in a synchronous manner. And so if you have some, for example, asynchronous operation, it will not know until it's completed. Okay. All right, so that kind of covers the high-level execution models in CliWrap, which there are 3. And you can always like build your own, of course, because at the end of the day, it comes down to extending the existing piping model in CliWrap. But To that end, I also wanted to show how the piping model actually works at a low level. So we can go back to our example where we had this code, where we were executing Docker CLI with some argument and used execute buffer racing. And instead of using execute buffer racing, we're going to implement it directly. And I'm not going to write it out myself. I'm just going to copy paste and explain what exactly is happening here. So first of all, we need some place to store the output and error data. And to that end, I created some string builder instances. And CliWrap offers on every command a way to configure the pipes. So here, when I wanted to write the outputs to the string builders, I can just use with standard output pipe and use one of the factory methods to point it to the string builder. With standard output pipe takes a pipe target as a parameter, which is also the same for error pipe because they're all outbound pipes. And pipe target is just an abstract class that you can implement yourself, which consists of one method. But most of the time you don't need to because it has a lot of factory methods that handle different use cases. So in this case, we would be using string builder, but we could also be using either to delegate to basically handle each new line separately in its own delegate, which is what Maxim was asking. We can write the output to a file directly by specifying the file path, to a stream by giving it a stream reference, or we can merge multiple outputs into one and have a command that runs and writes to a file, triggers a delegate, and also, let's say, also adds lines to the string builder. And we also did the same for standard error pipe here. And if we run this command or run this program, what we'll see is basically what we already saw before. So we got the output, which is the container ID, but instead of using the high-level execution model I mentioned earlier, it's just using the base level piping model to do the same exact thing. So execute buffer basically removes all of that code and replaces it with a much simpler approach. But the piping model can also still be useful in some cases if you want to have, if you need some, specific complicated piping setup. Another option that I wanted to show is that, like, instead of using toString builder, you can not buffer it and also handle everything as all the output and error as it comes in. But instead of using either the pull-based or push-based streams, we can just do it on a lower level by using a pipe target, in this case to delegate. So here we would be writing all of the output and error data to delegate each time a new line comes in, which again results in pretty much the same behavior because ultimately it routes it to the console. This could be useful again, like if you have a long-running process that you want to handle the data, you want to do something with it. To delegate also works with async delegates, so it doesn't only have to be synchronous, and things like that. You can also use toFile and toStream or other configurations. The kind of benefits you see in using this library compared to PowerShell scripts. The difference between the PowerShell scripts and CliWrap mostly is the fact that you can use CliWrap more sort of idiomatically from a C# or F# code. So a lot of the times you either need to interact with an external interface. For example, if you're working with media streams like videos and audios and you want to use FFmpeg, which is pretty much not available as a .NET library, or if you're again like building tasks that interact a lot with infrastructural code, or if you just want to write your DevOps pipeline in C# or F#, that is also an option. So using CliWrap kind of like moves that layer onto a different stack altogether. So instead of PowerShell, you would be using C# and F#. I can see that the library can be helpful to set up the environment before any integration tests. Exactly. This is also how the need for the library kind of grew for me, because that's what I was using it for, and also why the examples are all about Docker, because a lot of the times I just have tests that have like database dependencies, like caching, like Redis dependencies and things like that. And using CliWrap allows me to easily start them up and shut them down as I'm running those tests. So that was quite helpful. So about going back to the piping model, another cool benefit is that besides the different pipe target configurations and the sender output in error pipe methods, you can also use the pipe operator. So this exact same thing can be rewritten as this, which is a little bit shorter. But the difference is that instead of configuring those pipes using methods, we just use a pipe operator. And the way it works is that the command just has a bunch of pipe operator overloads for different situations, such as, for example, when you have two delegates. So if you have a delegate that you want to use to handle the output stream and error stream, you can just pass them as the tuple. And it's sort of reminiscent of how you would do that in a terminal, which is also kind of convenient when you have a more complicated piping setup. In this case, we can see that we are running this Docker command as it without detaching. As we can see, we have a lot of output and error produced to our console. Another thing is that we also have in CliWrap, we also provides cancellation support out of the box. So you don't have to deal with the different cancellation token handlers and stuff like that. You can just use the token directly and pass it to either execute async, execute buffer, listen async, observe, and other methods. So here we will be running a command that runs forever, let's say ping on Windows, and we want to cancel after 6 seconds. And it's really easy to do with CliWrap again, by just creating a cancellation token source or passing cancellation token from somewhere else. As we can see, after 6 seconds, we got the output and the program terminated. Okay, so questions. In terms of security, can we use this tool to find out connected users remotely? If we wanted to cancel the session from a connected user, can somebody help me do that? It comes down to, I mean, if there is a command line tool to achieve what you want, which I assume would be a system built-in tool, then yes, CliWrap can help you do that. You can automate pretty much anything you're doing from a terminal using your C# or F# or any other .NET code. And if it's possible to do from a terminal, it's always possible to do from CliWrap. This is basically the design goal, I guess, of the library, to provide an interface that is very similar to terminal, but accessible from programmable means through your C# or other type of .NET code. Okay. All right, so moving on to the piping model, I just wanted to show a few more complicated examples and also highlight why the pipe operators might be sometimes more convenient than the different with standard output pipe methods and such and such. So one example is using the FFmpeg tool. So I have it already downloaded and I have a sample video, and I just wanted to show an example here. So I have a video that I can just show that just contains a sequence of frames of our planet rotating. And I can use the CliWrap's piping model to take that file as a pipe source and then pipe it into FFmpeg, which is a CLI for handling and converting different media streams, and then use the whatever the output and error that instance of FFmpeg produce write it to the console. So you can see there are actually two different piping operators here, and it creates a pipeline of 3 elements. The first one being the standard input, which is sourced from a file. The second being a command that takes that standard input. As you can see, I'm not passing the file name or file path in any way, and then writes it to a different file. And then also, while the command is executing, all of the output and error is written to our console. And again, like we can handle it other ways, either by writing progress as it moves along, or handling errors and things like that. So if we run it, we can see that we get some output as FFmpeg is doing its job. And eventually it finishes. We can go to our directory, and we can see there is a new file where the same video is now in a different format. So FFmpeg is a CLI that it can do a lot of things, but here we just used it to convert one video from MP4 into WebM format by also saving about 3 megabytes of space. And in order to do that, we sourced the data for the input to that program from the file system using the pipe source factory method from file. Like with the pipe target, also has different other factory methods, like you can have in-memory data that you can source from. You can have, and you can use another command, which I'm going to show later, from file, which we just saw, from a stream, or just like from a basic in-memory string as well. A more complicated example of that same thing would be to, for example, take a YouTube video stream and then pipe it into FFmpeg to convert it to a different format. So in this case, I have some YouTube video, and I'm using another one of my libraries, which is called YouTube Explode, to get it. And then this library allows me to just get basic .NET stream, which contains the data for that video. And once I have that stream, I can use the pipe operators to simply take that stream and put it through FFmpeg once again, without saving it to the file system, and create an MP4 video, regardless of the format this video comes in, which is probably, something else. So if I run this again, or rather run this instead, we can see FFmpeg is doing some work. And the coolest thing about it is that we're basically taking a stream, a .NET stream from another realm, in this case is another library, and piping it to a completely unrelated CLI, which is FFmpeg, and it just understands what to do with it. So at the lower level, it just pipes data, raw binary data, and converts it as a media stream into a different video format. Similarly, we can do other things. We can source the stream from anywhere else, and using the piping model allows us to merge different operations that would otherwise be sequential into a continuous atomic stream. So instead of downloading the file ourselves, or separately, and then using that file to feed it into FFmpeg to convert it, we can just do that as a single action, single operation, without using extra file system space and, I guess extra code as well. So let's wait until it downloads the video and converts it. Shouldn't take that long of a time. And if you have any questions in the meantime, you can also ask them, as there's just one more example that I want to show. Should be how long is this video again? This was a video from like one of the previous talks that I did on this subject. Okay, it's 3 minutes and 42 seconds. So it will be around twice as much time that we need to wait for it. So I guess we can just scrape this code, wait for it to finish, and move into the next example so we don't waste time. And the other example that I wanted to show, which is the process-to-process piping, which is something that I discussed in the beginning of this talk, is very hard to do with process, but it's process class, but it's very easy to do with CliWrap. And one example of it is, again, using FFmpeg. We can use our existing video that I showed earlier of the map or of the planet, use FFmpeg to take that video and, let's say, take only the first 5 seconds and convert it to WebM format, and then, without saving it to any output file or anything like that, pipe it to another instance of FFmpeg, which takes that video output that it created and saves it into a different file using a video filter called reverse, which makes the planet go, well, the other way around. And the coolest thing about it is that we kind of just like chain 2 processes together, and using the pipe operators, it's really easy to do because it looks like just a sample of code from, functional languages that had support for piping. Because all of this looks just like a set of sequential operations, even though in reality, this process is launched first, then its standard input is routed from the output of this process, which is launched second. And then as the second process is executing, all of its output and error data is written to our console. So let's just wait a little bit for the previous demo to finish, because I wanted to show, in fact, that the video was downloaded since we're so close. And maybe somebody has any questions in regards to what I've shown so far. We have about, I guess, 20 seconds until it's done. Usually it runs faster, but I guess I have slower internet today. Yeah, no questions so far. Can we run this tool from smartphone? Yes, you can actually. So basically, as long as the process class is supported, which CliWrap uses under the hood, you can use CliWrap anywhere, which in most cases, you can even use that on mobile devices and automate processes there, as long as they can run on those devices in the first place. Can we see what exactly part of code is running task 1 or task 2? What exact part of code is running? I'm not sure I understand the question. I guess, oh, you mean like, both of them run at the same time. So in this case, when we execute this command, both of these processes are actually started pretty much at the same time. So the dependent process, in which case this second part of the pipeline, is started first because it needs the input from somewhere else, and then the input is provided through that process by reading the output from it. So they're both running at the same time. They're not like one running and then it's done and the other is running, but instead this one is running, it's writing output, and that output is immediately written as input to this process. So there's nothing stored on your file system. There's no buffering. Everything is basically streaming. And so our YouTube example finished, so we can actually see the video we downloaded, which was from the JetBrains conference. And as you can see, it plays well in my VLC media player, which for that, we just downloaded a stream from YouTube and piped it into FFmpeg to convert it to MP4 format. Now, finally, we can also test this one. So just as a reminder, we're using this video, which is a planet rotating in, I guess, this direction towards the right side of the screen. And if we run this set of commands, which are piped together, we're going to take that video, take only the first 5 seconds, and then reverse it, and then save it as a different file while also writing the output and errors to the console. And now we have video altered. As we can see, it rotates to a different side of the screen, which, is something FFmpeg did for us, but we could automate it very simply using CliWrap. If we were to do the same thing using a system diagnostics process, it would have taken us a lot more code than what you see on the screen, which is just 19 or even 18 lines effectively. Okay, more questions. CliWrap task 1, CliWrap task 2. Yeah, like I said, both of them are running at the same time, I guess, for most cases. I mean, you can also pipe the output. So at any point, like here, I could also do, if it's under output pipe, or actually I can't do that, but I could use pipe target merge to combine like one, let's say, command and another output if I wanted to see a progress of like this specific execution instead of this one. But in essence, both of them are running at the same time, and I guess it doesn't really make much sense as to which exact part is running at what time. Oh, by the way, where task process ID comes from one of your first examples, the custom task implementation. Yes, so CliWrap, when you call execute async or execute buffer async, it provides a custom task, which is not just a regular task. So let's just say execute async. You can see this is a command task, and if I should probably be able to, there we go, navigate to it, and it's basically a normal task that just has process ID, which can be useful to determine what exactly is running. It works as the normal task because it has the get awaiter implementation, which just uses the underlying task that it has through from other code. So basically, it makes this kind of usage as simple as this kind of usage, where you also want to access the process ID for whatever reason, while also being immutable, because all of the 3 states of execution, which is not started, started, and running, and then finished running, completely separate. So if you're referring to process ID, it's always going to be available, because even if the process has exited, it's always going to be there. If it runs simultaneously, can task 2 finish before task 1? I mean, theoretically, yes, but the way it's set up here is that task 2 takes the data from the standard input, and so it will run at least until it has read all the standard input, and the standard input won't be complete until the first task finishes writing it. So in this example, it's impossible. You use the piping operators to build pipelines that make sense. So when the next command relies on the former command or the previous command, and use that to build out complex pipelines that would be harder to do in code otherwise. How does task 2 understand it will get more input from task 1? It does so using the fact that under the hood is just the normal .NET stream class. And in a stream class, when you call read async, it only returns 0 when the stream is completely done and there's nothing else to read from it. So until it either waits for the task to finish and it doesn't finish, or it gets some result back, but it's not 0, it's some data, it will keep on reading from that stream. And that's how it signifies the completion, basically using just normal .NET primitives. So I guess that's all the questions so far. This is all for my demo. So I'm going to go back to the presentation, which is basically me concluding it, saying Thanks for joining. If you want to learn more about CliWrap, it's an open source project, which you can find using this link. I'm also going to post it in chat in a second. And if you want to talk to me directly, you can find me on Twitter or elsewhere and send me a message. And I mean, if you also want to get some help or have questions about CliWrap, I also have a Discord server, which is listed on the CliWrap repository where other people can also help you.